Let's talk about curve fitting on the TI-83 Plus or the TI-84 Plus, or in other words, finding the regression equation, also known as the line of best fit. What we're going to do here is I'm going to read through this note card, and then we're going to go through an example and apply the note card. So first I'm just going to kind of read through it. The first thing you always want to do is clear the RAM in your calculator, 2nd plus 712. There could be, data from a previous problem. Maybe your window's been adjusted to some other problem, and it's just always easier starting off with a fresh calculator. So clear your data. Number 2, you want to press the window key and then set your the parameters of your window using the data within the problem, and I'll show you what that's about. You have X minimum, which is your lowest X value, X max, which is your highest X value, and so forth and so on. X scale, Y scale will always be 0. Number 3, you're going to enter the data into L1 and L2 by hitting the stat key and hitting enter. That will bring up L1 and L2, where your independent or X values go in L1 and your dependent or Y values will go in L2. Number 4, you want to turn on your scatter plot. And the easiest way to do that is when you go to Y equals, right up above Y equals, you'll see plot 1, plot 2, and plot 3. And you'll go up to plot 1, just scroll your cursor up there and hit enter, and it'll highlight it and go back down to Y1, and your scatter plot is turned on. Then you want to graph the data, and you'll see the graph. And then we want to set up the designated function, meaning that we need to find what type of regression equation we're looking for. And you get there by stat and scrolling right to calc, and there's several to choose from. Today we're only going to be working with linear regressions, but in the future you may be given a set of data and you may have to decide what type of regression it is. So you'd have to put the data in and look at the scatter plot and determine what parent function does this data most likely resemble. And so you would have to determine that on your own, but today again we're only working with linear functions. And then finally, very important, putting the equation in Y equals, and there's 2 ways of doing it. First, you can simply type it in after the calculator gives it to you, or you can go through these little steps here and it'll put it in Y equals for you. So let's look at an example, and let's go through this note card and see if we can apply this. Okay. So our example here, it says the following table shows the number of calories burned per minute by a person walking at 3 miles per hour. You need to recall that typically when you have a horizontal T-chart, the independent or X values across the top, the dependent or the Y values are across the bottom. So going through here, it says sketch the scatter plot of this data and label the axes and the scale. I'm going to leave that to you to do that. There's 2 ways of doing it. One, you could simply look at what you have in your calculator once you actually find your scatter plot. 2, you can, using your own scale, the x-axis, you could possibly label it like, since your X values are 100, 120, 150, 170, you could possibly do it in increments of maybe 50s. So maybe you have 50. Something like that for your independent values. And then for your dependent values, your maximum is 5.9, so maybe you can just go 1, 2, and then just roughly do a scatter plot on your own, just graphing those points. The first one will be 100, 2.7, which is going to be about right in there somewhere. That'd probably be the easiest way to do it, and I think that's what we're looking for here without actually using our calculator. B says to sketch the regression line in a different color. So I guess we'll just go ahead and go through the motions here. 120 comma 3.2 is going to roughly be right in here. 150 comma 4. 170 comma 4.6. 200 and then 5.4. Finally 225.9. It looks something like that. And then so B says to sketch the regression line in a different color. In other words, you're just going to take some other color that you have and you're going to draw this line of best fit through there, and it kind of looks like that. It's not necessarily going to go through every point perfectly. The regression line, also known as the line of best fit, is called the line of best fit because best doesn't necessarily mean perfect, but it's just the line of best fit. C says using 2 points from the data find the slope and the approximate equation of the line. I guess I'll go ahead and look at this as a review of writing equations using, we're going to do this by hand. We'll be finding the slope, then we will be using point slope and then writing the equation in that way. When I clear this, all this data is about to leave. Well, I won't clear it right now, I'll just go ahead. So I'm going to create myself some room, hopefully. So if I want to write the equation of this line, I need 2 points to find the slope. Well, I have 100 comma 2.7. I got to fix that. I have 100 comma 2.7, and I have 120 comma 3.2, and then I just want to use this information x1, y1, x2, y2 to use my slope formula. Slope meaning or being y2 minus y1 over x2 minus x1. So if we have an xy here, and I have an xy here, this can be x1, y1, this can be x2, y2, and then if I plug it into my slope formula, y2 minus y1 is 3.2 minus 2.7 over 120 minus 100. Now, something I discussed with all of you guys at the beginning of the year is we usually don't use decimals, and the only time it would be appropriate to use a decimal is when you basically started off as a decimal. And here we have decimals, so it's okay to have decimals. And typically with linear regression or any types of regression, it's okay to use decimals. So 3.2 minus 2.7 is 0.5 or 1/2. And then 120 minus 100 is 20. And so 0.5 divided by 20 is 0.025. So that's m, my slope. So now I want to use point slope, which is y minus y1 equals m times x minus x1. And I'm going to plug in a point, and I can pick either one. I'll just use y1, x1, y1 here. So I've got y minus y1 is 2.7 equals m is 0.025, and then x minus x1, which is 100. And then just simplify. Solve for y, distribute, solve for y, add 2.7 to each side, and you're done. So if I distribute here, I have 0.025x minus which is 2.5. Bring the rest down. Simple review. Oops. Add 2.7 to each side. This goes away, and I get y equals 0.025x plus 5.2, I believe. And so this would be the equation. Is it not 5.2?
Negative 2.5.
Oh, let me correct this really quick. Negative 2.5 plus 2.7 is 0.02 or 0.2. That's a 0 there. So it's just 0.2. So this would be my equation, y equals 0.025x plus 0.2. And so that would be C. We found the slope was 0.025. We found the equation was y equals 0.025 plus 0.2. And that was all basically reviewed. Now we're going to get into using the graphing calculator to find this. So it says on part D, it says use a graphing calculator to find the equation of the line using linear regression curve fitting. Find the correlation coefficient from the calculator and tell if this equation is a good fit for the data. So we got to do a couple of things here. First of all, we have to set up our calculator to be able to show us the correlation coefficient R. Okay. Let's just deal with it right here. So if I'm going to find my correlation coefficient R, I have to turn the diagnostics on my calculator. If you hit second 0, it brings up the catalog, and you want to scroll all the way down until you find diagnostics on. It's not letting me skip down, so let me just keep going. Okay, so you want to keep going until you find diagnostic right here, and you want this on, diagnostic on. So hit enter there. That should turn on our diagnostics. So this will give us our correlation coefficient R. So now what we have to do is we have to put our values in. These values here, we want to put these in for our L1s. We want to put these in for our L2s. But we also have to adjust our window. As a matter of fact, that's what we need to do first. So I'm going to put these values in my calculator. And what I want to do first before I do that is I want to go to my window and I want to adjust it. Looking at my data, looking at the x minimum, I want to look at the smallest x value. The smallest x value is 100. I want to give myself a little bit of a cushion because when we're setting our window, it's like we're framing our data in. So I want to give myself a little cushion. So maybe I make my x minimum a little smaller than 100. Maybe I make it 95. Then my x maximum, my largest x is 220. Maybe I make it 225 with a little cushion. And then my x scale and y scale, well, I'll make sure they're both 0. My smallest y value is 2.7, so maybe I make it, I don't know, 2. My largest y value is 5.9, so maybe I'll make that 7. And my y scale is at 0. Once I have my window set up, and this is after we cleared our data, our RAM and our calculator with the second plus 712. Number 3 on the note card says to enter the data in L1, L2. So I go to Stat and hit enter right there on edit. And I didn't clear my data, so let me clear these out. This is why you should clear your data first. You won't have to go through these steps. But what you want to do is you want to put your x or your independent variables in L1, your y's and your dependent variables in L2. So I'll go ahead and do that. And be very careful with this, because this is where a lot of errors occur, typing something in wrong or leaving something out. And then my y's. And it's very important that you put them in the ordered pairs that they're supposed to be in. Okay, so now that I have my data in, I already set my window up. Now I need to turn on my scatter plot. So I go to Y1, and if I look up here, typically this is already blank, or it's not highlighted rather. I need to go up and make sure that this is highlighted. So I hit enter on it and make sure it's highlighted, and now it's on. And now I can graph it. When I hit graph, there's my data. Those are the points that I just put in right across here. And as I was telling you before, we are only working with linear regression today, but there will be a time possibly in the future where you'll have to decide what type of regression it is. But this looks like it's in a straight line. And so now what we want to do is we want to actually find this linear regression, or the equation of this line of best fit. So what I want to do now is I hit Stat, scroll right to Calc, and number 4 is linear regression, where it says AX plus B. You're used to MX plus B, where M is the slope, but here in the calculator A is the slope. So I'll hit 4, enter again. And so we have a lot of stuff going on here. First of all, we see that our equation here is y equals A, which is this 0.026, then x minus 0.0169, so forth and so on. That's my equation. And I'm going to show you how to, one thing you could do when you're working with irrational numbers like these decimals, I would always suggest at a minimum, if you're going to round to the nearest thousandth place, 3 decimals. But I'm going to show you how to make the calculator paste this equation in for you. This R right here, this is your correlation coefficient. And the closer that this number is to 1 tells you that it is a really good fit. So if this number is closer to 0, it's not a very good fit at all. The closer it is to 1, the better fit it is. And if you'll notice, the slope of our scatter plot is positive. That's why our R coefficient is positive. If the slope of our scatter plot were negative, then the R coefficient would be negative. Okay? So the closer to 1, the better fit. So how do I get this into y equals without typing it in? You go to vars. Oh, first you go to y equals. You have to be in y equals first. Once you're in y equals, you go to vars. You do number 5 for statistics. Scroll right to equation and hit enter, and it'll paste it in. Sometimes there are issues with it. Sometimes you'll get an error, especially when you're working with exponential functions. Just make sure your variable's in there and you're good to go, but this is fine. Now if I hit graph, notice my line of best fit goes right through the points. And now I can answer some questions about this function or this graph. So my equation would have been, when you write your equation, you're welcome to round it to 3 decimal places, maybe 0.027x. And then whatever, minus 0.017. That would be fine to write it on for the worksheet. The correlation coefficient is going to be 0.999. Compare the two equations, meaning, is my line of best fit pretty accurate? I would say it fits it okay. It's pretty close to what we came up with. Remember, when we found the equation of the line earlier, we were just using 2 of the points that was in the data. This line of best fit, or regression, uses all of the points. It takes all the points into consideration. F says find the number of calories burned per minute for a 160-pound person walking at 3 miles per hour. I'm going to leave F and G to you. They are simple questions that you would use things like, I'll give you an example, second trace, and if you hit enter on value, you can enter any X value and it'll tell you what Y is at a specific time when X is a number. You could also use your table by hitting second graph. Your table will come up, and so if you're talking about X being a whole number, you can find the corresponding Y values there. Remember, if you're looking for an X value that is outside of the domain, sometimes you'll be asked a question. And the question will be asking you about an X value or an independent value that is outside of the domain in which you set your window. You'll get an error if you do that. So you'll need to go back and reset your window in order to be able to put those X values in. And so I hope that helps you out. That's a good review on linear regression.